Another draft physics or draft science here on YouTube video presentation. All right, try to make this as brief as possible on the subject of energy generally, more specifically the distinction between the types of ways of measuring it, momentum versus something like kinetic and potential energy. Physics has two elemental simple equations, mv equals, and this more modern 1/2 mv squared ways of measuring what they call energy. This would be kinetic. This would be in newtons, this would be in joules. Simple translation would be this joule is 1/10 of a newton, just to break it into a simpler context. And the fact is depending on how you look at two things that have the same momentum can end up having different kinetic energies, and even in circumstances where there is no potential energy or any other influence. So physics basically accepts having two fundamentally different answers, two different specific answers that can vary dramatically, hundreds of percentages in terms of being not the same. So the simple argument I would make is all energy is, a joule would be, is moving an electron a certain amount of distance in a certain amount of time. That's energy. The truth is, it doesn't really matter the time. We're just talking about moving. We're just talking about the fact that material things move in space, and it takes energy to move them. I would argue that the space is really just made out of two things: the energetic bits, the bits moving the speed of light, and the matter bits, which move where the force forces them. So energy is best understood as there being two kinds of things in the universe, force and matter, and it's just the interplay between the force and the matter. Where the matter is tells the force where it's going to be reacting, and it's really just a matter of the force has energy. It moves. When it interacts with matter, it moves slower while it moves the matter, and that, in essence, is the interaction between force and matter. So force is consumed by matter moving, and we call that energy. And we more specifically recognize when there's imbalances in force, that is, there's more force on one side of an equation than there is force on the other. That's when we say something has energy, because it's going to lead to there being movement in matter when there's an unevenness in the force that the matter is existing in. So this really comes down to, it's made the most illustratable by a simple scenario where you have two objects. One object has half the mass and has, in theory, this one would have half the mass, and this one has 1m, and they have different velocities proportional to that difference in their mass. So this one would have a higher velocity because it has less mass, so we could say it had a velocity of 10, and this one would have a velocity of 5. Now these two objects would be described as having equal momentum, okay? mv on both sides is going to be the same, and it's their momentum as a measure. But if we use the modern equation of 1/2 mv squared, we'll see that this object has twice as much, this object going faster, the lighter object. The faster object would end up having twice as much. So if this number was 100 in momentum terms, their equation says it's 200, and the other object is only 100. It only has the momentum factor. Obviously, I'm saying that's just nonsense. This energy can never be recovered. So they say there's 200 joules. They say there's more energy. Yet they'll never find an experiment where they can actually extract that extra energy. They're only going to be able to extract this energy from any experiment that collects energy completely. So that's the catch, is there's lots of different ways to try to capture something's energy, and some of them leak. You lose some of the energy in the process of attempting to capture it. But if you do have an honest experiment that captures all of the energy, these two objects contain exactly the same amount of energy. That energy is something you collect. So when falling in gravity, you could understand it as basically just being, you have a bucket, and the gravity comes down at a certain rate, and it just matters how long you have your bucket in the gravity. It doesn't matter how fast you're moving your bucket, which way you're moving your bucket. The fact is, it's just how long is your bucket exposed to the rain will tell you how much you collect. And that's the real definition of your energy, is what have you collected. To move the heavier object 5 miles an hour needs the same amount of little bits of pushers, okay, if it was weight or if it was gravity, as it takes to do this over here. There's no 4 times as much energy. There's no, all of that is just talk. It doesn't have any, there's no mechanical basis for it. There's no theory for any notion that because you double the speed of a car, say it's going 30 miles an hour and you double it to 60, by their equation, it's saying that this car has 4 times the kinetic energy that this one has. Well, it only has a doubling in the velocity. It's only got twice as much momentum. It only has twice as much energy. And if they do any honest experiment to detect the pushing power of the two vehicles, that pushing power will be exactly the same. It'll be exactly proportional to twice as much. It's only twice as much energy at 60 miles an hour, not 4 times as much energy. Twice is a lot. So obviously, and it's not, we as humans are hard, we can't judge how many joules are taking place based on what it sounds like or what it looks like. You have to test it with real science. If they tested it with real science, they would find that this duality of equations is just a nonsense, that the 1/2 mv squared was poor science in its origin. There wasn't any convention that came to this conclusion. It was just a curiosity of history that it got popularized as a notion based on a couple of misunderstood experiments. It's just as bad as somebody taking the ferrocell or and drawing a bunch of conclusions about what magnetism is. The experiments gave them a misimpression, dropping objects into clay, versus a more clinical way of capturing energy. Clay provides I can give you logical reasons why clay provides a bias to things moving fast. Fast things will go further in clay than slow things because the clay has time to react, to reflect, to stop slow things, and it doesn't have time to stop fast things, and that's all. It has nothing to do with how much energy an object has. It just has to do with its penetration power, and that's a whole different measurement. And it doesn't have anything to do with any absolute, like energy. So it's clear that physics is just taking a terrible wrong turn with this equation. The original equation was just this mv squared part. I can still find modern physicists who are still just using this, and they're not even putting the half in front of it. That's how much they really don't care about getting the right answer. I mean, obviously, if you can have an equation, okay, and you call it, we're going to tell you how much energy it has in joules, and then you throw a half in front of it at some arbitrary date. Clearly you couldn't be taking your answer very seriously if you could cut it in half. If you didn't even realize you were half off, full 100% off, really. So I don't know if anything more needs to be said. It's just wrong. Momentum is the clear definer of your energy. If you have momentum, you have energy, you've captured real motion, and you have its potential, and you can transfer that motion. You can't transfer any more. You won't have 4 times as much because you happen to be lighter and going faster. Lighter and faster doesn't give you any more real energy. It doesn't mean you can transfer that to anybody. You can't make heat out of it. You can't make anything else. So when they say this has 4 times as much energy as this, there's no rational explanation. Well, twice as much. These two objects that have equal momentum, they're saying this one has twice as much real kinetic energy. And if they do a transfer one way, they'll say it lost, and if they transfer the other way, they'll say it gained somehow. This has a real kinetic energy, but if I did transfer this one's velocity to this lighter object, the obvious thing is it will travel twice as fast away, and then I somehow made extra energy. It has more energy. You can't have more. It won't have more in any experiment. You won't be able to extract it, by putting a generator on the wheel. Let's say you put a generator on the wheel, you'll generate just as much power, just as much real work capacity, okay, from this object as you will this object. They'll never be able to realize this 2x statement, that this one has twice as much kinetic energy. They'll never realize it in a real experiment. This is probably enough. Anyone who is aware of physics and all the experiments should be able to understand that there should be agreement that a formula duality is evidence of a problem, even in itself. But the fact that these two formulas provide such dramatically different answers, should be a pretty clear statement that this duality is a mistake, not some kind of fun feature. This isn't a fun feature of physics that you have 2 equations for defining energy. It's an error, and one of these is right and one of them is wrong, and I'd say all the evidence is this is the correct definition of energy, and this is just a nonsense of bad judgment 200 years ago. Yeah, that should be enough. And such, and so forth and whatnot. Yeah, I think so. It's been a Draft Science video presentation.